interest or focus is always that to develop interesting business models a little bit outside of our field data center provider. Yeah? And we saw there a really good opportunity for us to team up with a utility company, because as we all know, one of the major issues of data center operation is the power consumption. And that means we saw there a lot of synergies between both teams, and especially with green energy. Okay, you can also get green energy from any other maybe utility in the northern countries. But what we also want to achieve to really optimize reliability, which we see much better if you do this together with a utility company rather than have to do everything on your own. One simple example is that we are about to develop a concept, a power solution concept, to avoid any generators on site, which on the one side is a huge capex saving. On the other side, we are saving a lot of carbon emissions because normally you have to run generators each month on full load only for testing without any usage. So that's one big advantage we see. On the other side, we see also that we can offer much better service, much lower cost of energy than we might do if we really have to buy power from the market. Different to what you currently see, we run our data center cooling purely on water. How we are doing this? So we are using rear door cooling doors, which you can get from a couple of suppliers in the market, so it's not our technology, and connect this to a water system directly. And this gives us huge advantages. One, the building footprint and also the building volume. So we don't need big air plenums, circulating air. Everything is very nice, neat, and structured. We can do a lot of prefabrication of our whole construction work. And we are extremely energy efficient because we don't have to recuperate the energy from air to water, from water to air. It's a patent technology, a system patent, and it's interesting that why this solution had been developed, because there's a history behind there. So the inventor of this solution, Professor Lindenstruth, he's a professor on the University of Frankfurt and also on the Helmholtz Institute in Darmstadt. He had the task to develop a high-performance computing cooling solution in CERN in Geneva, where he had the challenge, how to get all this huge heat and condensed heat out of deep from the ground. So he had to find a solution how to do this. So and then he started developing this and did it on water-based only, without have to connect directly to the servers. So this was an initial idea. The other thing was that he said, okay, why do we always have to force air? Servers and storage force the air already anyway. They take the air in from the front and they discharge it on the back. So let's use this work which has been done already to really recuperate or to transmit the heat to the water system. That's very different than what you currently see. I'm very happy to be here because I mentioned before, or one reason why we see this connection between NDC and Skellefteå so phenomenal is the power and avoidance of generator and all the synergies. And this is exactly what I see you are catched up, this idea that there have to be more cooperation between energy suppliers and data center operators to really to explore this synergies, which not has been done so far.